Hello, welcome all. This is our third workshop with working with R. Today we're going to talk about plotting, specifically plotting and visualization, specifically with a library called ggplot. And I'll go more into detail on alternatives or why you would use that, what makes it special. My name is Christian Allen. I'm a software developer with the Digital Library, and I work also with the DSC for teaching and instruction. And we have two helpers with us today, Jamie and Tim. Jamie, do you want to do a brief introduction?
Sure. My name is Jamie Jameson, and I work in the Data Science Center as collection manager on the Dataverse repository, and I'm one of the carpentry instructors or helpers, and today I'm a helper. Tim?
Hey, I'm Tim Dennis. I'm the director of the Data Science Center in the library. And I also teach with the carpentries and provide consultation on data science. So feel free to ping us after the workshop.
Great. Thank you, Tim, Jamie. So just a heads up, when I'm working in our studio, I won't be able to see the Zoom chat, but feel free to put any questions in there or just yell out, just unmute and yell out. And Jamie and Tim will either answer the questions or they can flag me to slow down or to explain a part or to go more in detail. So there'll be three sort of main sections that we're going to talk about. The first, I guess, 25 minutes, we'll do a recap of the tail end of what we learned last week with Jamie. So that's just going to go over the different tidyverse, a few of the different tidyverse operations that we had used. So we used mutate, we used a pivot table, and we used a couple other means to manipulate the data. And that's okay if there's a lot of pieces there, and it's okay if you don't understand exactly how those work. The main takeaway is there are certain functions in R to manipulate your data in certain ways. So when I'm working with learners or folks that are working on an R project, usually, or any programming project really, it's sort of a rule of thumb that I use is if you're working on something and it's really frustrating and you spend more than 20 minutes on it, like trying to do something, definitely like reach out for help or look for other libraries that seem to address this problem, because most likely someone else has run up against the same problem and has solved it or has some means to solve it. So what I'm talking about, an example would be maybe you have a column that has multiple values in it and they're separated by a semicolon, and you were struggling, how do I split these apart? And most likely there's a function to help you do that. Someone has done that, and it's a matter of either reaching out to our community or colleagues who are working with R. So like another good example is dates are notoriously difficult to work with. So maybe you're interested in converting your date from time zones or things like that. You wouldn't have to do that manually. There is a library called, it's called Lubridate, that will help you manipulate dates. And that's just sort of an example. And the same thing in plotting and graphing. There's a bunch of different libraries to help you with visualization and graphing. So usually one of the most helpful ways to use as a starting point is if you see something on the web or you read something or you in a publication, hey, this has a cool chart, I want to emulate this. And that's a good starting point, working with, okay, you can sort of reverse engineer what they originally did, and you can duplicate that as well. So we'll be specifically using a library called ggplot to do plotting. I'm just going to share my desktop and go over what some of the common common ggplot operations and functionality that it provides. Let me share my screen. And this link is also in the Etherpad. These are some of the basic visualizations that are available, but almost any plot that you can find on the web, you can emulate with ggplot. I'd say that there's a number of different plotting libraries, but usually ggplot is the most ubiquitous with R. It's the most heavily used. So if you're working with an organization or a company, this is one of the most popular, and it's good to know just some of the basics of it. And there's no right or wrong to charting. You're free to use whichever charting mechanism you're most familiar with. So if your organization uses Tableau, Tableau is fine there, or Excel, Excel is fine as well. Whatever you're most comfortable with is usually the answer to accomplish your task. But the nice thing about ggplot is it comes with a lot more esoteric options that may not be available in some other charting packages, and you can also manipulate it to for very, very specific types of charts. So if you you can essentially manipulate every element on the chart. So you can really dive down into the details, where maybe with Excel or Tableau, you're kind of limited to certain options, like you have to place labels a certain way or something like that. So if you have a publication that's expecting charting in a very, very specific way, ggplot allows you to manipulate almost everything. So everything that we'll go over today is heavily configurable. So this is something that's really nice, and it's also really annoying with ggplot, because you could be like, oh, I want to maybe I want the labels at an angle so I can read them. Well, yes, you can do that, and then you can also have, you have to specify exactly what angle. So you could have it like 20 degrees, 40 degrees, so that there's a lot of options you have with it. So the first thing we'll do today is get our data in a format that is conducive to plotting. So we're going to make sure that we're all on have the same data set from last time, and it's just manipulated in a way that we have some numeric columns that we can work with. So I'll share my our studio screen. And these are the steps to replicate this exactly. And I'll specify exactly what you need to cut and paste in the Etherpad. I'll specify which line in a second here. But the first thing is, from last time, if you when we're here with Jamie, you should have a data folder, and in that data folder we downloaded a CSV file, and you'll still, if you still have that's great. We'll read that back in. So last session we used the read CSV function and the here function, which specifies which directory you're in. and you give it a directory name and a file to read. And in this case, we read the CSVs and we also specify, hey, if you encounter something that's not NA or not a null entry, set that as NA for our values. I'm going to run this and double check that we have it. So if I'll do view interviews and command enter to run it. Oops, and it's not found because I misspelled it. So I'll make it sure it's plural. Command enter to run. And this just is double checking that I was able to read this data in. So everybody should be at this point. So this is just the data downloaded from last week, just double checking it's still there and it's available. And then there's a long piped function that sort of is the culmination of everything we learned last week, piled into one command that does a bunch of operations. And I'll go over this quickly, and it's okay if some of this is a little confusing because they chose to put it in one gigantic command, which I don't. Ideally, we'd go through these bit by bit, but we learned a couple different operations I just wanted to call out here. So what this uses is a bunch of tidyverse operations. So tidyverse is a library that we learned last time that has a lot of convenient functions to work with data, and it allows you to chain commands. So you can pipe in a data set. So in our case, we have a data frame named interviews, and we want to take that, pipe it into another command, manipulate some way, keep that data and pipe it into another command and keep going until eventually we run through all of these pipes and then save that new data frame into one called interviews plotting. And so this does a few operations on our data that's just important to know or useful to know. So I think Jamie covered this briefly last time, but separate rows is a nice function that when given a column name and a separator value will split these into individual values. So if you have multiple values in a column and you want to split those up, this is convenient or if you have multiple values in a cell and you want to split those up into their own individual column and cell, this is convenient. Replace NA is if it encounters an NA value or something that's empty, if you want to replace that with a specific value, you can use replace NA. Mutate adds an additional column. So it's mutating your data set and adding a column. We talked a little bit about pivot wider. There's a few different pivot commands, but it's manipulating your data to shift it into a different format that's a little bit easier to work with. And again, we're using the separate rows, a few more mutate operations. And some of these also create some summary statistics. So in this case, we're using mutate, and we have a new column, and what's going to go in that value is the aggregate sum of a specific number of rows. So this is using the select command to say, hey, everything from January to May, sum that up, and put this in this new column that we're adding. And this is a really complicated, not really complicated. It's a pretty advanced statement here, so that's okay if some of this is a little confusing. We can go over it in detail if you have specific questions on how this is working or when you would use this. But for right now, I would just cut and paste it, and it's on line 251. So there's a starting at line 251 down to about 270. There's this command. So if you take that from the Etherpad, so I'll do this right now. So if you have your interviews, make sure you have your interviews data frame read in. And we're going to paste this command from the Etherpad. And then on the last, this is a multi-line command, but on the last line of that, I'll hit Command Enter, or you can highlight this and click Run. Either method will perform the same operation. So I'll just show you the example of highlighting. So if I highlight this and click Run, you shouldn't get an error, or that you'll see it echoed in your console terminal. And just to double check that this worked properly, if we click, if we type View and Interviews Plotting, and I'll hit Command Enter to run this, it should pop up a new window, and we can just peruse it to make sure it looks like it has some data in it. And if I go to the very end, you'll see the additional, this is just a way I was double checking to make sure that the previous function worked. We had two mutate operations that added a couple additional columns, and I'm just confirming that those are here. So this is the starting point. I wanted to just make sure that everyone's able to get to that point and has their data there. So I'll pause for a second. And is anybody having some trouble with that, or this command isn't working for them? Okay. So it sounds like everybody has the data, we're ready to go. If you came in a little late or just need to know, hey, what's going on here, Tim and Jamie will be happy to get you up to speed. But so right now we're just doing some prep work, getting the data in a format to use ggplot with. All right, so we're ready to do some visualization and plotting now. So similar to other operations, we have to make sure that our library is loaded. So you would probably get, you would have gotten an error most likely, but we'll just run this to confirm. If you were to open a brand new our script page, you have to load the library that you're working with, and Tidyverse includes ggplot. So it's okay if you run this twice. You don't have to run this, but this typically, if you had a brand new, you already have this loaded from working with. But if you were to start a brand new R page, you would load your library that you're working with, and the package that we're going to be using is called ggplot. And so most functions will follow a similar format. So we're going to work with data in some manner. So we have a starting point. So in this case, it would be our data frame. But so in general, I'm just going to type this as an example. So our data frame would be our starting point. And then we want to send that to a function to work with. So we can use if I hit the Shift Command M is like a shortcut, a keyboard shortcut for this pipe command. or this pipe character set. We want to send that data to our graphing function called ggplot. And then inside ggplot, we have so this is actually the very basic. So you could run this as it is. I can show an example. So we have a data set called interviews plotting. And I'll hit Command Enter and run this. And we can see this ran successfully in our console window. If we look down here, we'll see it echoes the command and we have no error here. And then if I look over on our right side under our tab by plots, we just see a big gray box, which is what we would expect. So the ggplot without any arguments sort of just lays the foundation. So we have a big gray box and we need to essentially add stuff to that. A visual, I posted a link in the Etherpad on line 289, which has kind of a visual representation of what we're doing. So with ggplot, you use the plus sign, and then you add elements to your plot. So you can think of it, you start out with this base level, which is data, and then we add on top of that a graphical layer, and then on top of that, we can add different graphical elements, like say lines or shading, or certain types of plots. And on top of that, we can add themes or labels. So they're additive operations that we're using with this. And so the way that it's structured is you add a plus sign and then the next operation that you use. So in our case, we started out with an empty graph, and usually one of the first things you want to define is the aesthetics of the graph. So or what ggplot calls it aesthetics, and it's the way it's structured is AES parentheses, and then there's a few different arguments that you can use in here. So the most common ones you'll see are defining, okay, what column do we want to assign to the x-axis? What column do we want to assign to the y-axis? And probably the most other common one you'll see is grouping elements. So you can also group elements in the aesthetic function as well. So where would you want to do that? You always need, in order to graph it, you need things in a numeric context. So you may want to create a summary or group items together. So a good example would be, which we'll go over one, but if you have if you have a column that has multiple values that you want to assign to sort of a single time series or length. So for example, if you had all of our names with different grades for the dates that we took a test, you may want to group those together by name, and you can do that in your R data frame, or you can do it in ggplot. There's no right or wrong. It's just sort of which you prefer. So in this case, we'll go over assigning a column to an axis. So the first case will say, hey, for our x-axis, we have, there's a number of members. So I'm going to look at my data here, and there's NO underscore members, or members. So we'll plot this on our x-axis, and then we also have a number of items. NO underscore items, which is in here somewhere. I may have already passed it. Oh yeah, here it is, which is our column that we created. So we'll be plotting the number of members and then how many items they have. So we'll type in our column. It's also, our studio is pretty smart, and it's context aware. So if you start typing something here, it knows that we're working with this data set because of the way that this command is structured. So if you start typing x equals something, it knows, hey, I'm expecting a column name here, and it will sort of autofill. So if you can also click on it just to help with typing. Another, I just want to call this out, another common structure that's exactly the same that you may see, so you're not surprised, is another way that folks commonly use ggplot is instead of explicitly stating the data set before and using a pipe to send that data in, it's also common to see the data set explicitly stated. So you may also see a command like this. So data equals interviews plotting. And so these commands are syntactically the same, or they end up doing the same operation. But it's just so you're not surprised if you're reading someone else's code. It's just a different way of, you can either define the data set explicitly or you can send it to a ggplot. So in our case, we're going to announce our data set and then send it to ggplot. So we have our data set, we have our function ggplot, we have our x-axis, we're going to define our y-axis. And we'll run this. You can either highlight it and hit the run button, or I'll hit Command Enter. And so we see a little more now. We see our X label and our Y label and some values. So we know that this is helpful for debugging as well. So sometimes if you're working with a plot, you're like, hey, nothing's showing up. But it recognizes these column names, so it just helps to narrow down, like, okay, well, it's finding the data, but maybe my data is not in the right format or something like this. So this is the layering approach I talked about a little bit earlier. So without these aesthetics, we just have a basic plot. Then we added an X and Y axis, and we explicitly told ggplot which columns to use, and we can see that based on the column values that it read the data, and we see that this, it's interpreting it because the values are within the same range, but we don't see any. The next step is to actually tell ggplot, hey, I want you to show this data in a certain way. So what I mean by that is we have these data points, but we haven't told ggplot how to show them. So it would ask us, oh, okay, great. You want to see it? Do you want to see it as dots? Do you want to see it as a bar chart, a histogram, a line plot? What do you want? So we can do that by adding the plus sign. We'll hit enter, and we'll add the geom function, geometric function for how we want to show this data. So it's geom underscore, and if you type, there's a whole bunch here, you'll see probably close to 100 different values, and we'll go over maybe 10 of the most common ones. And so we had talked about, hey, let's just see some basic points. I just want to see some data to make sure that we're pulling this in. And we'll have geom point with no arguments. And I'll hit Control Enter here. I'm sorry, Command Enter. And in the lower right-hand corner, I'll see each of these values represented by a dot. Well, there are some flaws here, and we'll go over that. But I just want to make sure everyone is able to get to this point. I'm not sure why I have I'm not sure why I have this error here, but maybe it'll go away after. But this can be, running this the first time can be kind of tricky because if you just run a section of it, it won't work quite right. So you have to run this whole chunk of code, and the format usually is to have the plus sign at the end of the line, and then tab indent for each of the functions that you're using. So I just want to hold off here to make sure everyone can bring up this plot. And that's a big accomplishment. You have your first plot with R with your data. So I just want to pause here for a second if there are any questions, and we'll go into refining this.
Someone was asking about the code before the data. I have to get the line numbers, and I'm going to put that in the chat. And that's just the code to get our data and shape for the graphing.
Yeah. So yeah, like Jamie had mentioned, if you just were to run, if you were just to run interviews, which is the data set without our manipulated values, this will not work. So I'll show you with the error that I'll see, because it's missing a column. So this big chunk here adds a summary column. That's a numeric that we can plot. I may be able to but any two numeric columns you could use if you want, if you were in a pinch and you're like, hey, I just want to test this out. I was just looking at our interviews column, and there's a years lived. So maybe we want to show the number of members versus the years lived. We could change this to years lived, and I'm not sure what this would look like, but this is on the original data set. So if you're in a pinch and just want to try this out, this is guaranteed to work. And we're working with a slightly modified data set that uses a summary column. So I'll change this back to num items. And there's a variety of different geom functions. Probably the most common ones you'll use are the line. This will look kind of weird, but I just want to show it as an example. And it's just because this looks kind of wonky because it's not, well, there's probably several reasons it looks a little weird, but one of them is a line chart probably has some sort of date or progression or time series on the bottom, so it looks a little jittery here. But just to show that this is completely independent of your data, so you can change the aesthetics of your chart or plot without messing with the internal structure of it. So you can layer. So you could say, if you want to change it to a line chart, to a dot chart, it's not very expensive from like a code perspective. So I'll rerun this with geom point, and I just want to call it again. This plus sign at the end of this line signifies okay, this is the end of a layer, sort of a layer, and we're going to add another piece to that. And you can keep appending these. So you could do this, and we'll see where we have multiple copies of it. But the format has to be at the end of the line. It's like inconsistent if you were to add it here. Sometimes it works, sometimes it doesn't. Like R does kind of its best guess. Yeah, it didn't like this, but so this does have to be here. This will work if it's all on one line, but it's kind of not the best format. Usually it's you add the plus sign, then hit enter. So and it will automatically indent for you. So if you're just reading others' code, this is generally the most common format. So there's a couple different problems here. One of them is if we were to look at our data, we can see that there may be multiple entries that have the same values. So there may be 4 items and the number of members is 5, and there may be multiple entries in this dot. So it's difficult to tell, and this may be a value, maybe not. If you're looking at this, like you can't really tell how many are here. So there may be like 10 entries that have this same XY value. There may be just 1. We can't really tell from this current graph. So there's an option based on the number of values to change the opacity of the dot, and that is an argument to the geom point function. So if we type alpha equals and then a value from 0 to 1. So in this case, I'll do 2, 5. I think the instructions have 5, but we'll see what this looks like. So, and we can see that if I run this with a certain value of alpha, where there's an overlap, they're a little bit darker, so you can tell, okay, there's multiple values that sit in here. So this is a little more intuitive. We could see there are multiple values that sit in this same section, and this can be changed a bit. So the higher you go, I believe, the darker. So if we were to do like 0.9, this shouldn't look that much different than if we didn't have alpha at all. So this almost, I mean, there may be a slight difference in here, and then if we do 1, it'll be very, very light. So almost too light. So there's no really, a lot of this is sort of trial and error to how it looks with your data. It may be slightly different for each data set, and it also depends. We'll show adding color and a couple other means of differentiating between the different values. So I'm going to change this back to, we'll change this back to 0.25. I'll rerun this. And another option is, so we have these, they're overlapped on top of each other if we have multiple values. Okay, that's acceptable, but there's another option that we have to spread these apart to show that they're the same value but close, and well, that doesn't make any sense exactly. They're the same value, but we'll change them, add a slightly randomness so we can see that they're close to each other. And that's called geom jitter. So instead of geom point, I'll type geom jitter and run this. And we can see that, so here there are 2 dots that are slightly close to each other, or the dots that were on top of each other are moved a little bit. We can see this looks much different than if I were to geom point again, just so we can see the differences. Actually, I'll copy this. And just so we have both of these. And so this is geom point, and then geom jitter, which randomly moves them a little bit, so you can see sort of the dispersion of values between those that are very, very similar. And we can also control how much they're moved from each other. Right now, I don't remember what the default is, but we have similar to geom point, we can add alpha to change the opacity. So I'll keep this at 0.5. I'll hit comma and enter for readability. You can put all this on one line, and we'll change the width and the height, which says how far do you want, how far do you want this from the original data point to move. So we'll run with just some slightly different parameters. So this looks a little more tightly coupled, but you can see it's gray, and it moved, or it's light gray for some of these, and it moved some of the dots that are the exact same value. So this is just a takeaway. If you have a lot of data that is the same values, and you want to see the counts or the number of values you have, that may be helpful from a data analysis perspective. There are probably better options. You can which we'll go over. You could have like a box plot of the distribution and things like that. Another option is you can change the value of the color for each of these. So this will work also in geom point, but I'm going to use our existing graph that we have here, and set color equals, and in quotation marks put blue, and this has to end with a comma, and I'll hit Command Enter, and it has a different shade of blue. There's this can be red, green, sort of the standard variety of named colors, but you can also give it, if you want a very, very specific color, you can pass a RGB or a hex code for the color. So there's a very, very specific color. You can designate that. So we can see we can have red and blue, a couple different options. We can also assign, so this is interesting, we have all one color. We can assign the color based on a value in our data set, which is helpful. So the geom jitter and geopoint also have an aesthetics option. So I'm going to delete our color option here. And I'll add enter, and I'll hit tab a couple times so these line up, but that's not required. And similar to our ggplot, we'll add AES, and color equals, we have to give it a column name that we want to assign colors to. So for example, if this data point is plotted and is of a certain value in a column, we want to have that a different color for each value. So maybe we want to show how each village is represented. So we can use the village column name. And I'll add a comma here to make sure these all line up. So the only one that doesn't have a comma is the last argument. And I'll hit Command Enter. And we can see it automatically adds a label for us, and it also adds our colors and assigns them to a village. So these, each of these colors represents the village values that match up with the number of items and number of members. So it's a nice way to quickly group your data to be able to see it represented. And I think I'll take a break here, or just we've been going for about an hour, and we're just about. I was going to do, when we come back, we'll do a group exercise just to hammer some of these points home. But I wanted to just stop for questions before we break. Go ahead, Jamie.
I noticed one thing when I first typed this in. Village, the village, the column name doesn't have quotes, and I first did it with quotes and nothing happened. I found sometimes when R does or doesn't use quotes, is something I run into. So if something doesn't work, maybe no quotes. I don't know if that's more confusing.
No, that's helpful, Jamie. I think some of the something that's definitely confusing with R that I don't have a particular explanation for it, but with experience and just seeing other code, you know when to use like an equal sign versus single quotes versus, in general, if you have quotes, you mean the literal string, but in this case, we're referring to like a column value, and usually, not always, unfortunately, but usually if you're referring to a column, you don't have quotes and you have the actual column name. What's also kind of disappointing here is in nested functions, sometimes RStudio doesn't have the context and can't do the guessing for you. So in this case, like, oh, I want color. And so it correctly figured out, oh, these are the different options for the aesthetic function. But then when I do equals, I would expect it here to show the columns to help me out. But it doesn't do that, or at least in my version. So I'd have to actually type village here. But yeah, I wanted to stop and break here for about 10 minutes. But so the takeaways, we're laying the foundation for reading in data to a plotting function, which is ggplot. We've seen that we use the aesthetic function to sort of grab our axis values. So in this case, we have 2 axes, but you can have X, Y, Z depending on the type of graph that you're using. And then we lay on the visual elements. So we'll add some more on top of that. If we want to change, for example, the next question may be, hey, these labels are kind of ugly. That's okay. We can change that by adding another option on top of that. X label or Y, or the graph title. So we have a couple different options that we'll go over to continually add. And then we've also seen that once you define your data set and how you are structuring your data, that you can apply a different visual element to that. So if we want to have a line chart, a box plot. Go ahead, Jamie.
Oh, somebody is asking about a secondary y-axis. I'm not sure actually what that is.
Yeah, maybe I'll stay on during. I'll let folks go for the break, and then maybe we can answer it, because I want to clarify what that means. If you wanted to have like different scales or something like that, we can talk about that a little bit. But I'll hang around for 10 more minutes, and I wanted to let everybody have a break, get up and stretch, grab some tea or coffee, and we'll be back at 5:35. And we'll do a group exercise to solidify some of the points that we go over, and then we'll go into some of the more advanced functions of R. Okay, well, I'll see you guys at in 10 minutes. And then Jamie, who or yeah, if someone could.
Evelyn, I don't know if you want to
Yeah, thank you, Evelyn.
off mic. Maybe.
Yes, two different, so potentially if you need two different scales, yeah, on the two different axes, which I've used. So can you just add that to this language somehow?
Yeah, I think, could you give me an example of, so in this case,
So you're doing, let's just say, I don't know about this data set, but let's
Sure.
say you're looking at, kind of on one axis, you're looking at total population. The other axis, you're looking at, some change or a rate or something like
Okay.
that. And you want to look at them both together, in some kind of a line graph, let's say.
right, yeah, yeah, no, absolutely. You can have that type of change, and you can also squash it if you wanted to show like one value logarithmically compared to the other or something like that. So yeah, you have a number of different ways to manipulate it. And I'll try to find an example where it uses that, and we can show that.
Great. Thanks. Go take
Sure.
a break. Sorry, I didn't mean to.
No worries.
Encroach. So.
Yeah, let me see if I can find an example quick. All right, we'll get started again. I wanted to show one more function that's really helpful, just to get a different view of this data that shows some of the different options we had. So I'm going to just scroll back up and rerun our original plot to take a look at it. So this is sort of our stock plot with geome point. And one of the flaws in here was that a lot of these were on top of each other, so we couldn't really tell how many different instances of these values were available. And we had a couple different ways of dealing with that. So we used the alpha option in geome point to make it a little bit lighter. So we saw 0.5. I'll rerun that, and that helped a little. We also saw, well, we can move them around a little bit so we can tell, and even that may not be sufficient depending on what you're trying to show. And then we saw coloring, different options. So also with the aesthetics of the point, and so we can combine all those and try a slightly different view of our data that may be more appropriate for this. So previously we had used an additional aesthetics option in our geome point, where we can also use that at our main in our main plot. So up here, I'll add color equals village, and I'll just delete the alpha for now so we can see what this would look like. So this is just adding one change where we add, instead of adding the grouping color in the geometric function, we moved it up to the aesthetics of at the plot level, and I'll run that. We'll see what that looks like. So we can see it looks very, very similar. We have these, but there are overlapping dots here, and we have another option that will change the size of the dot based on the number of values are the same. So the function is called geome count. And now if I run this, I'll type a brand new. So we'll do our data set, interviews underscore plotting. We'll add our piping character. I'll hit enter. We'll add our plotting function, ggplot, open parens. We'll add our aesthetics function. We'll add our x-axis, number of members. We'll add our y-axis, y equals number items. We'll add an additional color function. So we want to group these by color, by the value in a certain column. So that will be village. Then we'll add an additional geome function, geome count. And let me just go back to, and now when I run this, we can see we have a couple new things to call out here. Is we can see the values here. So even if they're on top of each other, we can see there's a blue value inside of a green, and we see the number of times that they occurred. So this, if you wanted an exact value, this may be more appropriate. And then it has a scale from the minimum to the maximum values that it encounters. So this is, a number of different ways of doing the same thing, and this is just a different way of grouping the data and showing the number of values that may be helpful. So the takeaway is that there are multiple types of these geometric functions that you can add that add some aesthetics to the value. So we'll put some of this together with some different columns that we have. So previously we used number of members, number of items. Maybe we want to do something similar to this, but we'll use something like the number of rooms per village. And then maybe we want to color that by the wall type or something like that. So if we have, so we'll create a scatter plot with the number of rooms by village, and then we'll group that by the respondent wall type. We first have to define our data set that we're working with. So we'll do interviews, plotting, and we'll add our pipe. And we need our aesthetics function, so we have to define an x-axis. So we'll say village, and then for our y-axis, we'll say rooms. And I'll just leave the default now. If we were to do something like geom point, we can see this is not, it's helpful, but there's a lot we can do to improve this. So we learned a couple different options. We'll use geom jitter to move these around a little bit. And let's group these by respondent wall type. So we've, similar to how we had grouped these by village, maybe we wanted to split this up and look at a slightly different way. So we can use the same concept that we learned, which in our geom jitter function, we used an aesthetic function again. We're going to assign a color based on a column, and the column is respondent wall type. And this time it auto-filled it for me. And this is tricky. So this is where this ends. So I want a comma here, a comma after the first set of parentheses, because we still have some additional arguments we wanted to add. And so we'll add an alpha. We'll start with 0.5. We've got a comma. We'll add width and height, which is just moves these around to certain values that we decide on. 0.2, and a height will also set as 0.2 or 0.2. And let's see, and I'll hit Control or Command Enter. And we can see this looks similar to the concepts are similar to our last graph. In this case, we're breaking up by, we have the number of rooms and the village at the bottom on the y-axis, and the number of rooms on the y-axis, and then these are grouped by their respondent wall type. So it's still probably not ideal for telling this, but these are an option that we have to. So this is applied to just a couple different columns that we've seen. There are additional we looked at geom point, geom jitter, and there is a few other options that are commonly used. So we'll look at a few others. There's the most common one is one of the most common uses is box plots. So we'll define another graphing function. We'll define our aesthetics. So we'll do a similar graph. We'll have the x-axis equals the respondent wall type, and we'll define the y-axis the rooms, and we can add a plus sign to add an additional layer, and we can see what this looks like just with points. So usually something nice is if you just run geom point, it's kind of the default view, and so I usually will run this just to make sure, okay, we're getting some data showing up. It's okay if it doesn't look very nice, but it's a starting point. And instead of geom point, we'll use geom box plot. And I'll hit Command Enter. And in this case, it shows the points and the box plot graphics, so we can tell the quartiles and the outliers by glancing at this plot. So that's a nice option. You can also combine this with others. So maybe we want to add these points, but we want to move them around a little bit. So we can use what we did above as well. You can layer these on top of each other. So we'll also have the individual points show up in addition to the box plots, and we'll use geom jitter and change this to alpha. I'll add a comma, color equals red, comma, and the width and height will change again to 0.2, comma, height equals 0.2. And I'll run this. And we can see that all these points show up now. So we can, before we saw a lot of the points were sitting on top of each other. So this is just a different way of seeing all these. So you can sort of see the distribution a little bit easier rather than looking at the box plot itself. You can see the actual values in here, how this is. So it looks like cement only has one value. Burnt brick seems to be like equally distributed between these values, and then I guess it's sun bricks are mainly on the lower end. So you can get a quick overview, and there are a variety of these. So another option that we had was like if something common you want to do is maybe a histogram of your values, and we can do a quick bar chart. So we'll do define our data set, interviews plotting, and we'll define our graphing function, ggplot. We'll define our aesthetics. In this case, if you only, we'll give it an x-axis. And if you only give it one axis, ggplot will make its best guess, and it'll say, oh, okay, I think you want the number of times this occurs to be the y-axis. So essentially, it takes a best guess. There are ways to explicitly define the count, but this is if you have a quick, if you want to have a quick graph and not have to explicitly define, or if you don't have a column for the count, you can just only state the x-axis, and then the type of geom plot that you're using will conform to that. So in this case, we're going to use a bar plot. And so on the x-axis, it will have an entry for each wall type. And on the y-axis, it will have the count. So I'll interview. Okay, so I got an error, interview plotting not found. And I misspelled this. So I'll go back up here and type interviews plural underscore plotting, and I'll rerun this. And we can see that the result is a count of the values we have in each of these entries. So for each category of wall type that we have, it gets an entry in the X column, and the Y column is populated with the number of times that occurs. So we can also use, similar to what we had used above, which is grouping or using aesthetics in the plotting mechanism. So we used it in geom jitter, where we defined, oh, color, we want to break these apart. That may be helpful in this plot as well. Maybe we want to split these apart and we just have the count. That's not very helpful. Maybe we want to know, okay, well, how is this broken up? And we can create an aesthetics function and assign a fill value. In this case, I know previously we had used color. These functions are arguments are slightly different for each of the geometric types. So it's just something to keep in mind. In this case, the value is fill equals our column name that we want to assign the values to. So in this case, we're going to use village. And the result is this is a little bit more readable. And there are some other options. I think when we get to labeling, you can add the explicit number in here, or you can, which we'll see, is you can group these and have these values side by side, which is a bit easier to read. But with just a minimal amount of code, you can see how you can put these together and group them. I'm going to change this to color, because I'm just curious if what the difference would be here, if it doesn't even have this value. Okay, so I was just curious if I had used color previously in all these, and geom bar uses fill. So I see what the difference is. So fill actually colors the entire value, which it looks like color just gives you the outline. So depending on what you're doing, that may be a little bit nicer, but I think in this case, fill. The other option I just talked about, like, okay, this is kind of readable, but this is, if we look at burnt bricks, maybe this is 25 for this village, and then you have to add this up. I don't know, this may be like 15 exactly, but if we had these side by side, it would be a lot easier to read. And there's an option that you can give an argument called position, and for bar plots and dodge, we'll give these side by side. So let me make sure I have, and you can, after each of these arguments can be, I usually put them on there on the next line just so it's a little more readable, but you can have it all on one line if you like. And I'll just double check that I have this typed correctly. I'll hit Command Enter. And now it sets each of the values next to each other for each village. So it's a little more readable now. So I'd say, depending on what you're trying to show, there's a couple different options. If you're short on real estate, and you prefer to use this, there are some options for, I'll have to double check, maybe Jamie or Tim can find some code real quick, but you can actually fill in like the value, the actual number value for each of these. So if you're tight on real estate and you're like, no, I don't have, there's no room for to split these into their own columns. I need this in a publication. You can have like a little arrow and the actual number of these values listed here. So let's add this back position equals Dodge, and so now we'll add some labels to each of these. So maybe I talked about this a little bit earlier, like, you add these on top of, each of these are layers on top of each other. So we've added the basic plot, which is sort of the background, and we've defined our data, and then we've added on geometric options. And then another layer we can add is tweaking the labels that we have. So let's do a brand new plot that's a little bit different, that has some options for us. So we'll do percent wall type. Actually, I'll take that back. We can use this same one, my bad. So similar to what we've done before, if we add a plus sign, the function that we use for labels is labs. And there's a bunch of different arguments here. You can see it guesses, or it tells you some of the options. Some of the basic ones we're going to use are the X and Y axis, and then the actual column name. So some easy wins we have is, let's name the title of this. So we'll say count of wall type by village. I'll add a comma. We have a few other ones we want to use, and we want to change the x-axis to something more explicit than count. So we'll do wall type count. I'll add a comma, and for our y-axis, we'll add we can just add this. We can use wall type. These values that we're using here, the reason that they're in quotation marks is these are actual strings, so these don't have to conform to anything. What you type in here is what will appear on your chart. So even if I had some, just some garbage letters, that will come up on the chart. It doesn't have to match anything. Where it's going is defined by the argument name that you're giving it. So in this case, the title will be this value, the X label will be this value, the Y label will be this value. So I'm going to make sure my parentheses are closed, and we'll run this. And we can see now we have our new title, we have our wall type, we have our wall type count. There's some funkiness where the center, it's not centered quite right, or there's a couple of different options for labels that we can use that are more in depth. But the takeaway, I guess I want to give is you have the option to manipulate any of these. So something that's really common is that I've encountered a bunch of different times is particularly on the x-axis, if you have values that are really long categories. So in these cases are well, we don't have that many categories in this case, but if you were to have, say, 20 types of wall types, these would start to overlap. These values would start to overlap with each other. So you have the option of, you can turn these to print out at 45 degrees or 90 degrees to try to be a little more judicious with your graphing real estate. So just a takeaway. And you also have the option to move the legend around. If you don't want the legend over here, you can have it in the top corner of the graph. There's a couple different options for that. And maybe Jamie or Tim can post some examples of just tweaking that. I don't have any on hand with me, but I can find some to show the different options for that. Another option is that's helpful is having multiple graphs on broken apart by type. So in this case, maybe we wanted to have a separate graph for each village. Right now, these are all sort of on top of each other, but maybe we wanted to have these split out when it makes sense. So we'll define a slightly different chart using the percentage of each house in a village. So we're going to create a brand new data frame, which I'll I had held off on this because it's a little bit complicated to type this in. So I'll add this. Feel free to, you don't have to type this in exactly. You can cut and paste this code from the Etherpad because there's it's a little complex. So just in the interest of saving some time, the idea was to show the percentage of wall type from each village. So if cement only takes up 10% or something like that, and then we wanted to show those each in its own graph rather than all on its own. So let me interview plotting. So we're gonna create a new data frame out of our interview plotting data. I'm going to create a pipe. We're going to use some of the tidyverse functions that Jamie taught us last session. So we're going to filter by respondent wall type, where it's not equal to cement. And we'll do a count. We'll group by the village. Oops. And then we're going to add an additional column, percent. and usually this is part of a longer lesson, so we go through this more in depth, but that's okay. For purposes of this, it's okay to cut and paste this section. On group. And so I'm just going to paste this in the Etherpad. On line 344. Oh, I realize the Etherpad's down. Okay, well, unfortunately, the Etherpad's down, so I'll go over this. So this was just sort of a setup to show how to break apart each of these graphs to show it in a view that's called the faceted view. So it's, yes.
Christian, just paste it in the chat if you can.
Oh, okay. Yes, thank you. Thank you, Tim. So we'll show our unfaceted plot first. So we'll do percent wall type, ggplot, yes. So we have our x-axis will be the village. We have a percent column now that we created with mutate, so that will be our y-axis. And we'll use a function or a function argument that we used before, the fill value. So we'll fill based on respondent wall type. And we'll use a geom bar. And we'll define a stat value and a position value. Oops. Let's see if I got this. And I think I missed, let's see, percent wall type. Let me just run this again. So I have a syntax error. We'll find where this is. Let me run this again. Oh, I see. Filter. Let's see. Interview plotting. Let me just make sure I have. So we have.
Interviews. I make that same mistake. It's interviews.
Ah, thank you, Jamie.
I've done it.
I should. Yeah, less. So I'm gonna. Let me copy this again. Sorry, I led you astray on this one. This is the correct. Yeah, it looks like Jamie had posted this. Thank you. Okay, no, we didn't get an error. So we're going to run a sort of a group plot with our percentage wall types. So this is similar. It's just this is a setup for what we're doing, and we've seen before how to add some labels, so we can quickly. We can just skip that. That's okay. If you wanted to add labels, we can do this real quick. Labs. Plot title goes here. So the takeaway is that you can use this labs function when you add that on as another layer to define different labels, and you can have X and Y in here. And then in addition, we can split this up into, so in this case, we have everything on one graph, but maybe we want to group each of these graphs slightly differently, to have a plot for each village. And the option to do that is called faceting. And you define facet wrap, tilde, and then the column that you want each of these to facet on. So in this case, we'll choose village. And this doesn't, so I think this is, let me see. Oh, I see. So this is fine. This doesn't look exactly what we had changed, because I'm going to change the X and Y axis. I reused this. So if we change I repeated the X axis. So in this case, we're faceting it on village, but we're also using the X axis as the village. So we have that repeated. It really doesn't make a lot of sense. So we should probably have a different value for our X axis if we wanted to show this. Or I guess we could even do this if we wanted. So in the lesson plan, they do it slightly differently, where they have the x-axis defined as the respondent wall type, and they split this up based on the village. So this makes a little bit more sense, where we have a graph for each village on its own, and then this is an example I was talking about, where we have these labels, and they're sort of they're unreadable, or not unreadable, but they're a little bit difficult to read. The options that we have here is another, we can continually add layers on top of this. So we've seen with this, we started with our basic data layer, where you define where your data is coming from and how it's defined. So the X and Y axis. We define the graphical elements. So in this case, we have a geom, we're going to have a bar plot. We define some of at the label level. And then we talk about splitting each of these graphs into its own component. We can also apply themes as well. Thank you, Jamie, for posting that. And so there are a number of different themes. So by that, I mean how this is shown, the sort of the fonts, the structure, this like gray hash mark in the background, or the default colors. There's a bunch of different themes out there. So where you would use this is sometimes maybe certain publications require certain themes. There's like themes that are used by like the New York Times or 538. So if you like that style, most likely there's a theme that you can apply, and you get all those elements for free, essentially. So we'll use we'll change this back. So this is color, but maybe we're going to post this in a print paper that only has black and white. So we'll do theme BW, and we'll add an additional component. so this, we can run it without this as well, but this cleans up the background grid to make it blank, instead of having hash marks. Although so this is still in color. I thought this would be black and white, but maybe theme BW is not black and white. Maybe theme basic. There's also, let me try theme dark. I see. So it doesn't affect the actual elements.
You gotta remove your color on your bar, geom bar, I think. Or where do you have the fill?
Yeah, this would.
Oh, but you can set the color to. It's tricky. Okay, sorry.
Yeah, if I remove this, it would not. So this is, yeah, this is a tricky thing with. So one thing I have experienced, I guess this is important to call out in a real world, is, and Jamie and I have struggled with this a few times, changing the. So you can get colors really easily, kind of the default rainbow colors, and but there is a little bit of coding gymnastics you have to go through if you want something that's an exception. So for example, if you were looking at this plot and you said, hey, I want the defaults for everything, but I want all the burnt bricks to be yellow. There's a little bit of extra work you need to go through to sort of override the default values. And so I'll follow up on how to get this to be shaded values. I guess let me just change this. This may work.
Oh.
It's a little closer, but not perfect. That's still not. I was hoping that these would be shades of gray, but yeah, Tim, you had suggested just removing this altogether.
What was it you changed to get them all gray?
So we had the two big options we have for grouping these together are fill and color.
Oh, okay.
And you notice the most difference in the bar plots because it just colors the outline. So in this case, if I use fill, it fills the entire value.
But this is the kind of stuff you do when you get into wanting to make a really pretty plot. It's like very granular, and you can like toy with it in all kinds of ways to get it to look exactly like you want it, which is good.
And then, yeah, the main takeaway I wanted to show was this. It's not that impressive in this case where there's only 3 different graphs. The next one, I can demo it real quick. So, unfortunately, I don't think we have enough time to go through the entire exercise, but when you have like a dozen values or something like that, it's nice to have a bunch of different graphs. And they have a couple different, the example they have is splitting the types of items that a village has and showing those values. So the percent of, and let me see if I don't like cutting and pasting, but I can cut and paste this to show this example and then make sure that we have 5 minutes left for questions. So I'm going to go to the grab this off of the Etherpad. So I just wanted to show a more complex example with faceting, and we have to set up a data set to do that. So I'm going to we're going to grab percentage of items. So what this shows is, or the data set we're creating here is each particular item that a village, we want a graph for each particular item, and then the percentage that the villages contain of these. So this is a pretty complex operation. We're structuring things in a way so we can look at this data a little bit better. So if I view percent items, we'll have the items and then the percentage by village. So we can see like, okay, there's 42%, 40, or like 40% of the homes have a television, 58% have a solar panel, and a bunch of different items here. And so we have, the first step was just getting that data in a format that's plot friendly. So it's like category and then some numeric value that we can plot. And then we can use similar concepts that we had put in our previous plot, where we're going to define the X and Y, which is our village and percent. So we can see we have a village percent. So this is a numeric value that will go on the Y-axis. And we're going to have each of the items next to each other, which is the Dodge graphs. And instead of faceting on the village, we're going to facet on items. So we'll have a separate graph for each of these items. And then we'll set the standard theme. The theme is not required for each of these, but we'll run this. And we'll see maybe probably a dozen different smaller plots. So we have each of these. So and again, there's some fine tuning we can do. So you can see that the label, each of the village is labeled or is listed on here, but it only shows on the x-axis of the bottom category, on the bottom list of charts here. So there's some tweaking we can do to make this a little more readable. But it's the takeaway is if you have a data set, it has different categories. This is a quick way of splitting those up really fast to have separate graphs for each of those. The final thing I wanted to show. Okay, we have the final thing I wanted to show really quickly is one of the what would be the easiest one here? This I'm going to copy and paste an earlier plot that we did. Let me pick one here. Let's see. This is a good one, actually. So I have this geom count, which has number of items in a village, and it has slightly bigger versions for, or the width of the dot is based on the number of times that entry occurs. So I'm going to copy this. I'll put this in the chat real quick so you guys can run this as well. And so one of a common question we have is like, okay, this is great, but I want to put this on a web page, or I want to have this interactive in some way. You're kind of limited by this static representation of this value, or of this chart, which can be kind of annoying. And there's an easy way there's a sort of an easy win that you can use to make this web friendly. There's a package called ggplotly. I believe I already have it, but on mine. But if you type ggplotly into packages, you'll be able to install it, and then similar to other libraries, you can load this by typing library and then ggplotly. And let me see this real quick. That may not be exactly the, oh, is it? I'm sorry, it's Plotly. I'm sorry. The function is so in here. I led you along. In install, you would type Plotly. I already have this fed, and then to make this interactive on the web or on in your entry here or on the web, you can wrap this entire function in another function called ggplotly. So you can reuse all the code that you wrote. Just wrap it with the function ggplotly and run this, and now you can see if you hover over this, there's a bunch of different elements here, and you can have a lot more detail. So you can hover over items, or you can zoom in as well. You can select options, you can download the data sets. So we didn't change it. The nice thing is if you have a whole bunch of, the takeaway here is if you spent weeks writing your code, creating these static graphs, and someone says, hey, we'd like to have this on the web. It's not like, oh my gosh, I got to rewrite all this. You can download this additional library and wrap everything in this function, and you sort of get an easy win right out of the gate, where you can move this to the web or post this on the web. And that's a good segue into so Tim will be showing how to create our Markdown documents next session. And you have the option to publish to PDF or to a web page. And if you use ggplotly in conjunction with our Markdown, you can have an interactive web page that is generated right from our studio. So it's a nice way to end. That's an easy win that you can have. So all the plots that you've already written, you can make them interactive with just 10 or so characters, just wrapping that in this function here. And I hope to stop a little bit early, but we're at the bottom of the hour. So I wanted to just, if you have a chance, fill out the feedback form. Myself and the instructors will hang around for 10-15 minutes afterward if you have any additional questions, or maybe specific data or functions that you wanted more details on.
I just want to add that the R Markdown workshop is this Thursday. It's not going to be next week. So it'll be this Thursday, 4:30 to 6:30. Yeah. Please fill out the feedback form. I pasted it in the chat. And thank you, Christian.
Yeah, thank you guys for coming. This is a long lesson, and we crammed a lot in. So I realize some of it may be a little confusing, but we're happy to stick around. And if you have a specific data sets or plotting that you want to do, we can help out with that.